Hey everybody, I'm back. In this video we're going to talk about reflections in the x-axis and in the y-axis. So here we're talking about f of x again being my regular parent function graph. If we have a negative outside the function, in front of the function, this is a reflection of the graph in the x-axis. So it's called in the x-axis, but it doesn't have to necessarily be the x-axis that it's reflected over. But it's called a reflection in the x-axis. Basically, if it's a reflection over any horizontal line, it's called a reflection in the x-axis. So if a point xy is on the graph of y equals f of x, then the point x negative y is on the graph of f of x. And if it's just a negative in front of the function like it is here, it is going to be over the x-axis. But when we combine that with the shifts, especially a vertical shift, like we talked about in the previous videos, this isn't necessarily going to be a reflection over the x-axis. It's going to be a reflection over some other horizontal line. Okay, so what does this look like? Well, we're going to graph f of x equals negative x squared. So let me start by graphing just x squared. Okay. So here's our x-axis, here's our y-axis. Our scale is going to be 1 and 1. And just like I did in the previous video, let's make our parent function just x squared. And then the function we are trying to graph is negative x squared. So let me go through, because I want to make sure that we are very familiar with these parent function graphs. Let me go through what x squared looks like, and this is something you should memorize. It's going to make things move a lot quicker if you have it memorized. So x squared starts at 0, 0, and from there we go up 1, out 1, and that gives us our next points. Okay? So we're going to go up 1, out 1. Then we go up 3, out 1. Then we go up 5, out 1. And in your head, I really want you to separate the two moves. We have our vertical moves, which is up 1, up 3, up 5, up 7. We have our horizontal moves, out 1, out 1, out 1, out 1. And I want you to separate these in your mind, because when we get to compressing and stretching these, being able to visualize vertical and horizontal as independent things is going to be very important. So here's the graph of y equals x squared. And we've gone through this in a previous video, but I wanted to make sure that we were all on the same page, that we all understand the parent function of the quadratics. So that shape right there is something that you should know. Now, what does the negative out in front do to this function? Well, there's no shifting happening, so we should still start at 0, 0. The difference is now, instead of all of our vertical movements, since this negative is outside of the function, it affects vertical. It has an effect on vertical things because it's not inside the function. Inside the function would look like this. Okay? That's not what this is. This is outside, so it affects vertical. And what you see is what you get. So a negative on the outside basically just says do the opposite thing you would do vertically. So normally from this starting point 0, 0, I would go up 1. But instead of going up 1, I'm going to go down 1. But my horizontal actions have not changed. There's nothing here telling me to change what's happening horizontally. So I'm going to continue to stay out 1. So I go down 1, out 1. Down 3, out 1. Down 5, out 1. And this is what the graph of negative x squared looks like. Let's see if I can actually hit a few of these points while graphing. And so there is your graph of negative x squared. And that's what a reflection in the x-axis looks like. This literally looks like a reflection. If the x-axis was a lake, this looks like sort of a reflection in the lake there. Trying to make that look like water. I don't think I succeeded, but it's like a reflection in the lake of my original graph. Okay? So now let's look at reflections in the y-axis. Now you can see here that this negative is inside my function f of x. And so if it's inside, it affects horizontal things. And so now our reflection is over some vertical line, which means we're actually moving things horizontally. And so if the point xy is on the graph of f of x, then the point negative xy is on the point of f of negative x. Notice how it's the x value that gets changed. It's the horizontal that's getting changed. So here, the best way to illustrate this, you're not going to see any change if you do this with a quadratic, but if you do it with a square root function, we're going to see the change. So the difference here is we have this negative inside, and what that tells me, let me set up my coordinate plane here. So we have my x and y axis. We're going to go up by ones. Okay. I've already graphed the parent function for the square root of x, but I'll do it again very quickly. So g of x being the square root of x looks like this. We start at 0, 0. We go up 1 to the right 1, up 1 to the right 3, up 1 to the right 2, 3, 4, 5, up 1 to the right 7. That's as much as I can fit right there. And there's my square root of x. Okay, this should be a little bit more curved here. But there's the square root of x. Now we are graphing f of x, which is negative, the square root of negative x. And so because this is inside, it's going to affect horizontal changes. So vertically, in this graph, I'm still going to do what I did vertically for the red graph. I'm going to go up 1, up 1, up 1, up 1. But horizontally, I'm going to do the opposite of what I did in the red graph. So instead of going up 1 to the right 1, I'm going to go up 1 to the left 1. Then still up 1, but to the left 1, 2, 3. And then up 1 to the left 1, 2, 3, 4, 5. Up 1 to the left 7, which I'm not going to fit on this graph. But all my right movements have become left movements because my horizontal has been switched to be the opposite. And this is probably easier for lefties on this. This is like the one case where lefties have an advantage, is drawing this. So this is what a reflection in the y-axis looks like. And again, if we had a mirror that was the y-axis, this would be sort of that reflection in the mirror. Again, I'm trying to make this look like a mirror. I don't think I succeeded, but you can see how that's like a reflection in that mirror. Okay, I will see you in the next video where we will talk about horizontal and vertical stretching and compressing.